All right, so what we're going to do now is just spend some time talking about general networking theory. What are the different components of the network that go to build the what we call the topology, where basically all of the devices connecting together, and what are their specific roles? Now, when we looked at the CCNA blueprint, the main things that are going to be covered in this just general portion are what are the network devices, what are the pieces or components that make up the network, how do we look at different network diagrams and figure out based on someone's documentation of a network, what does that actually mean? We'll look at the difference between physical diagrams that talk about the actual wiring of the devices together, and then what's known as the logical network diagram or the logical topology that shows what is the result of our configuration, which is more indicative of how data actually flows through the network. We'll also spend some time talking about the OSI and the TCP/IP models, which we'll see are definitely going to be useful when we get into troubleshooting and when we go to verify individual portions of the network to figure out if I can't reach a web server, where exactly is the problem? Is it part of my layer 2 Ethernet LAN, or is it part of my layer 3 IP routing, or is it something higher at the application that I'm having the problem? So the overall idea behind this is that it's going to help us with documenting the network, it's going to help us with troubleshooting, and then from a vendor point of view, it's going to help them to build devices that work with other vendors or interoperability. So for example, you could have a Cisco switch that's talking to a Netgear switch, and there's not going to be any problems because they agree on the same standards of what's going on in the OSI model. We'll talk about some of the different network applications, like the difference in requirements between just normal web browsing and things like IP telephony or voice over IP, and then also how we can visualize by looking at the network diagrams how the network traffic flow is going to go through the network or go through the topology. And this last step, this is going to be one of the main goals of this class, that towards the end of the week, we should be able to interpret it at any point in the topology. If I were to browse to a website, or if I were to make a phone call over the IP network, as the data or as the packets are moving between the devices, what exactly is it going to look like, and what kind of decisions are those individual devices going to have to make? So like when a layer 2 Ethernet switch looks at a packet, what is it looking at in the data versus the layer 3 routers in order to actually make its decision and to send the traffic through through its different interfaces? Now, as a general overview, we could kind of break the network down into 4 main components, the first of which are going to be the endpoints, like our laptops or your servers or your IP phone, your smartphone. This is going to be what's running the actual application. And the overall goal of the network is to service the endpoints, service the applications, to make sure that they can browse to a website or that the financial data is going through the network. We have to remember that this is always the ultimate goal of the network, to make sure that from point A we can get to point B without any problems, and that we can get there based on what we call our service level agreement, or the SLA, where let's say, for example, I'm making a phone call. I want to make sure that I can actually hear the person on the other end, that their voice is not going in and out, or that every 5 seconds the call is dropping and I have to pick up the phone and dial again. The other portion is the interconnections, which is basically the physical cabling of the network, where in the case of like your laptop, it could be your wireless card, it could be your NIC card where you have the physical cable plugged in. It could also be the cables themselves, like what's the difference between a category 5 copper cable versus a single mode fiber cable, and then the different connectors that actually make up those connections or the interconnections. So for our scope, main thing we're going to focus on is the other two. The switches, which are going to be used to connect devices together to make what's known as the local area network, or the LAN, and then the routers, which are used to connect multiple LANs together to make internetworks. Or like in the case of the internet, it's a collection of smaller local area networks that routers are connecting together in order for us to go to google.com or to go to whatever other application resource we want. We'll see that the routers also are going to play an important role in choosing the path for traffic as it's going through the network. So as it's moving from the local area network onto the wide area network, where the WAN would be like your internet connection to your service provider. So the router ultimately is going to be making the decision of how does traffic get from point A to point B. Now, when we look at the different types of switches, we can put these into three general categories, or sometimes what's called in the Cisco world as the three levels of hierarchy, or their hierarchical network design. Okay, basically, you could kind of visualize this like a pyramid, where that at the top of this is going to be the central point of the network, which is called the core, and then as we go down towards the bottom, and as the network starts to get larger, that's ultimately what's connecting to the endpoints. Now, the switches that connect to endpoints, like our laptops or our servers or printers, this is what's known as the access layer switch, or simply the access switches. Then typically these access switches connect to what's known as distribution level switches, which some vendors call this the aggregation level. Then ultimately it's going to connect to what's known as the core level of switching, basically the center of the network where the vast majority of traffic is going to pass through. Now, in the case of Cisco's current portfolio, if you were to go to their website, under products and services, a vast majority of what we're going to be focusing on here is under routers and switches. So if we look at the way that they categorize their switches, it does get a little bit more detailed than just the three levels that I talked about. But we have here what's known as the campus LAN core and distribution. This is generally going to be the higher end devices, which have more what's called port density, basically the amount of cables that you can plug into the device, and also basically more processing power, so they can handle more traffic in the network. Then the access layer switches, these are typically the ones that would go in like the wiring closet on the floor of like your office, where your actual phone is plugged into, or where your actual PC is plugged into. Then they get a little bit more detailed for specific applications, like there's ones that are for data center applications, or ones that are for service provider aggregation or service provider Ethernet access, where the term aggregation basically means taking smaller portions of the network and then combining them into larger single points in the network. Like, for example, in the world of like original analog telephones, your single phone line, when it connects to the phone company, they would take, let's say, 20 phone calls and then put those over a single line, or they would aggregate them, combine them together for a single link that goes out to the rest of their core network. Now, for the if we were to look at like the specific models, in the case of the core and distribution, this is where you would find their most popular model of switches, which is the 6500, or the Catalyst 6500. This one's been around for a long, long time. As you can see, it says they're the flagship Catalyst switching platform. And this is basically the one that traditionally powers the center of the network, or the core of the network. Then as we get down towards the access layer switches, this would be ones like the 2900 switches or the 3500 switches. These are similar to the ones that we're going to be configuring this week. Now, what's nice about a lot of the Cisco product lines, when we're looking at either the routers or the switches, regardless of how expensive the switch is or how many ports it has, what are the features that it has, they all have the same interface. So when we look at the configuration of how do we build a LAN with the Catalyst 3500 series switches, if you were to do the same thing with using a 4500E or a 6500, the configuration is going to be the same. The commands that we use to actually make changes on the devices, the commands that we do to verify things, which are show commands, and then troubleshooting commands for which are known as debug commands, it's going to be the same regardless of what type of platforms that we're dealing with. But the key is that from a high-level point of view, when we look at the network, a lot of times you'll see it fits into this hierarchy where your access switches, that's where your endpoints are plugging into. Eventually, these are going to plug into the distribution switches, and then it's going to be eventually plugged into to the core. Now, you'll also see a lot of times if you were to visualize this, you're going to have your endpoints like your hosts or your IP phones that are plugging into the access. Then you generally have multiple access switches that are going to be connecting to the endpoints. So these are individual hosts. Then somehow these are going to connect to the distribution layer, and then eventually get to the core. Now, the idea behind this is that if we build a hierarchy in the network, where the first level of hierarchy, the core, second is the distribution, and third is the access, that as the network starts to grow, we wouldn't have to take every switch and plug it into every other physical switch in the network in order to add new hosts. So the idea behind this is that, let's say I have 100 hosts that are connected to the network. If I now need to add 100 more or continue to scale the network, the only thing I need to do is add more access level switches, eventually connect these to new distribution switches, and then they can be serviced by the same core, because this is where the real high-speed forwarding is happening. So typically this is where you're going to see the real high-end devices. Distribution is where you may have somewhere between the mid-range and the high-end. The access layer switches, these are usually the low-end platforms, where they're not going to be running many services when we look at the software functionality of the switches. Basically, their goal is just to get the traffic to come from the end hosts, somehow get into the core of the network, and then maybe this is where we have like our web servers, or this is where we have our database servers. So we'll look at as we start to build the local area network, or the LAN, specifically how do these pieces fit together, and how do we get the traffic from our end host, let's say host A, to our web server B, or to our database server C. Now, the same is going to be true of the routers. We can still put them into three main categories. Just the terminology is a little bit different, than they talk about the levels of the routers versus the switches. Where typically the first one is considered the branch router, where this is going to be some sort of low-end router that could be connecting like your remote offices, or it could be one that's at your house, which they use the term SOHO, which is small office home office. Maybe this is what you have connected to your cable modem or to your DSL modem. And then this is going to get us to our main offices, which are typically connected by what's known as the WAN routers, or the enterprise edge. Where you'll see the term enterprise thrown around a lot for these networking topics we're talking about. Enterprise basically means some sort of business entity that's using the network as just a normal day-to-day portion of their operations. Like if I run a retail store and I need the routers in order to get my point of sales machines in order to talk to my people where I'm placing the orders. So this is going to be the enterprise network, where the other end is going to be the service provider. This would be someone like AT&T, for example, or Sprint, that if I'm connecting to the internet, my traffic is going to have to go through them somehow in order to get to my other portions of the enterprise. Now, if you likewise look at the products, it's going to be separated similar to how the switches work, where we have the branch routers. These would be what they call the current ones are called the integrated services routers, or the ISRs. This would be like the 1900, 2900, or 3900 series. The ones before that, if you click on to compare the models or look at all of them, generally these ones are going to be, so for the branch routers, these are the ones that originally started with the 2500 series, which are, at this point now, they're like 20 plus years old. But the idea is that we're using this to connect typically remote offices to some central location. The ones that we're going to be configuring this week are 2600s, which are still considered branch routers. Then it goes up from there, where you would have like 1700, 1800, 1900. A lot of the naming conventions can get kind of confusing, how they use these numbers and how they relate to each other. But there's a really good document that, and for whatever reason, they don't publish this anymore, but it talks about the, let's see, the Cisco router performance numbers. It is this document here, Portable Product Sheets Routing Performance. Basically what this talks about is what are the different models of routers that they have and how fast can it send traffic. So this would give you an idea of how their numbering convention works and which routers are going to be better than the other ones. So for example, here, the ones that we're using this week fall into this category that is 2600 XM, where it says that the amount of PPS, or packets per second, that I can send, or the amount of Mbps, the megabits per second that can forward, you'd see that these numbers are going to be lower than some of the newer ones, like the ISR 2851. It says it can send 15,000 packets per second versus the 1500. So generally it means that it's going to get onto the network faster and it's going to be able to send more traffic. Now, I'm not 100% sure if the exam covers this as much as it used to. When I originally took CCNA and CCNP, a large portion of the exam was the product lines and like what are the different router numbers and why would you want to use one versus the other. But this is kind of a good just overall overview you can see of, for your individual application, if you're trying to buy a router, you would need to look at, well, what are the requirements based on the application? So I need to figure out what's the amount of megabits per second that I need to forward through the router, or what's the amount of packets per second. And then based on that, it can give you an idea of where in the portfolio is this specifically going to fit. So when we get up to the mid-range ones, which again we have the branch routers, that's going to be the low end. The WAN or the enterprise edge, this is where the 7200 router sits, where it's kind of comparable to the Catalyst 6500. This is the one that's been around for years and years. This is basically the core of their routing platforms, where it originally used to be part of the core, but now since it's an older router, it's starting to move down lower in the range. But you can see here also, it says for WAN routing, the Catalyst 6500 series switch also fits in here. So we'll see that there's some cases where the line starts to blur between when do you want to use one platform versus another, because one feature that this supports is what's known as layer 3 switching. So when we look at building the local area network, or the LAN, with the access layer switches, there's certain ones of them that can also run as routers at the same time. So where originally you had a separate switch and then you had a separate router that were performing separate roles, a lot of times nowadays you'll have maybe devices that are doing both roles at the same time, or even advanced functionality. Like you could have a switch that's doing your Ethernet switching, it can do your layer 3 IP routing, but then also maybe it's your firewall, maybe also it's your application acceleration, like something that load balances between your web servers. There's a lot of different features, specifically that the 6500 series switch does. Then lastly, we would have the service provider routers, the service provider core, where the top end one, this is the carrier routing system, or the CRS. This is what you would have in the core of the internet, like that AT&T would use to get their traffic from LA to New York, or to get it from New York to London, where typically these platforms are literally like hundreds of millions of dollars to build. So obviously we're not going to be configuring these ones this week, but what's nice about this is that when you're looking at some of these higher level platforms, like the ASR 1000, for example, the interface of this is the same as the ones that we're going to be using this week. So as long as you learn the fundamentals of the technologies and then how to apply the iOS syntax, you'll see that regardless of what platform you're working on, that it's going to extend to all of them. And that's one of the big advantages that Cisco's had over the years, that their operating system is very, very flexible. that once you learn it on one platform, you're automatically going to know it on all of the other ones.
So they've completely gone away from set-based commands?
For set-based commands, they've gotten away from. Some of these run a new operating system. The CRS and the ASR run what's known as iOS XR, which is like the next generation of that. But it's really, really specialized. So most engineers in their lifetime wouldn't really see that OS. As long as you know the regular Cisco iOS, it's going to be on 99% of their platforms. You'll also see that a lot of other vendors too, when they design their operating systems, basically model it after Cisco's, so that if you're using someone else's switch, the commands are going to be identical to what Cisco's are. Because last time I looked at it, it's still something like 70+% of the market share that they have for routing and switching overall. Okay, so as we get into the configuration of this, we'll talk about a little bit more where these fit in. When we start looking at the network design, like where would you put your branch routers, where would you put your WAN routers, and then what are the different roles that they're going to play in the network. Next thing we're going to look at is when you look at someone's documentation of the network, or basically a network diagram, how can we tell what is the end result of how the devices are plugged into each other and how the devices are configured when we're trying to get our traffic from point A to point B? So if I open up my web browser and I go to Google and I do a search, when my data actually goes through the devices, or what we call on a hop-by-hop basis, basically goes from one switch to a router to another router over and over and over, how can we visualize exactly what's going on behind the scenes? And the way we're going to do this generally is two different ways, with physical network diagrams and with logical diagrams. Now you'll typically see that when someone is documenting the network, you need to maintain these two separate sets, because the physical diagram is going to show you how is the stuff actually cabled together. So if one of the links goes down, like let's say I have a fiber optic cable that goes from here to Portland, then if there's a problem in the network, let's say someone is like doing construction work and they break the cable, I would need to look at my physical diagram to figure out how are those devices actually plugged in together. Where the logical diagram, this is going to show us what's the result of the data traffic flow. And this is one of the things that in a lot of the Cisco Press books, a lot of the other resources, they don't really make it as clear as to the difference between these. And it can get kind of confusing when you look at the diagram to figure out, is this talking about the physical topology or the logical topology? So we're going to look at both of these and how we can build the physical network diagram versus the logical network diagram. So again, the physical one, this mainly shows how are the devices plugged in, how are they cabled together. So from here you would want to know, like, what are the names of the ports that connect the routers. So I have an example of what the topology that we're going to use this week looks like, where this shows the 3 switches, the 5 routers, and then this test PC that we're using. So how are they actually physically wired together? Where I have 3 different switches. I have switch 1, switch 2, and switch 3. They have these category 5 Ethernet cables that are plugged in together, where on switch 1, I have port fast Ethernet 0/13 that connects to the other side on fast Ethernet 0/13. So then down the road, if I had trouble, let's say that I have this PC connected to switch 1, and for some reason it can't send its traffic to some server that's over here, I may need to know what are the physical cabling of the devices together. And this is mainly what this physical network diagram is going to show you. So when I connect switch 1 and switch 2 together, what's the port numbers? What are the type of interfaces? Like this, is this a copper cable? Is this a category 5 cable? Or is this like a fiber cable? Okay, the Cat 5 cables, these are the ones that look like your normal phone cords, where they have the RJ45 connectors, like that you would plug into your laptop. Where the fiber cables, we'll look at those a little bit later when we get into more specifics about the physical aspects of the network. But the key is that when you're documenting the network, you need some reference for this. A lot of times it's very difficult to try to troubleshoot some problem without knowing what's really going on behind the scenes with the physical interconnections between them. There's also another one that we'll look at that is the routers connected together with what's known as serial links. Now, a serial link typically is used to connect to the wide area network, or the WAN. This is what we would use like to connect to our internet service provider in order to send traffic between different remote offices. So we'll talk about the properties of these, like what's the difference if I were to run the PPP protocol versus the frame relay protocol over these links. But that's what these kind of like lightning bolts look like in the diagram. Typically that's used to denote a serial link, where the ones that are usually just the lines, most of the time this is going to be talking about Ethernet. So the main idea about the physical network diagram, again, it's going to be useful for troubleshooting our physical problems in the network. If there's something wrong with a cable, I need to know how this stuff is plugged in together. So I'll make copies of this for everyone, so once we're actually going through the configuration, we know what the network looks like. Because without this, it's going to be really hard to figure out how are the routers and the switches actually supposed to talk to each other. Now, the logical network diagram, this is going to be more of a high-level overview that tells you how the data is actually going to move between the devices when you're trying to go from point A to point B. So if I open up my web browser and browse to some site, I want to know based on the result of my configuration of the network. So things like the Ethernet VLANs or the wide area networking addressing, like in the case of frame relay, something that's called the data link connection identifier. We'll talk about it in more detail later. But this is typically the type of stuff that's going to be in your logical diagram. This is also where you'd see your layer 3 information, like your IP addresses, and also what your routing protocol design is going to look like. So typically, the logical network diagram, this is going to be used to troubleshoot what's known as layer 3 or above. And we'll talk about what these different layers mean and how they relate to the different operations of the network. But to kind of decode what does the diagram even mean to begin with, you have to know what basically the icons and the conventions that they use for the diagrams. Where you'll see typically that Cisco for PCs and servers, this is kind of self-explanatory, that this is a computer that's talking to the network. Maybe the server is like your email server or your web server, database server, where the router is going to look like this little kind of hockey puck. Where the switch that's connecting to the Ethernet LAN is usually denoted two ways, where we have that one, the little rectangle there, or in the case of a switch that's running layer 3 routing, it's going to look a little bit different. Then we have the serial links, which again look kind of like the lightning bolts. The Ethernet links are usually just the straight lines. And then a network cloud basically means any connection that we don't care about the details that are going on behind the scenes. So if I'm using ISP1 to get from the office here to some office in Chicago, I don't really care about what's going on in the service provider's network. So behind the scenes, from their point of view, it's none of my business. As long as I send my data to them and it comes out on the other side, that's really all that I care about. So any diagram that you see a cloud like this, it just means that there's some networking devices in there, but you don't really care about what the details of them mean. So we'll see as we build different topologies and we go through different examples, this is generally what the icons are going to mean. Now, if you want to use these for any diagrams of your own uses or like any examples you want to create, if you search for the Cisco Visio icons, there's a portion of their website, the network topology icons, that they actually publish these. And you'll see that there's different ones for basically all of the different types of devices that they make. So if you look at the full PDF, you'll see they have specific icons for different devices, what they mean. Like this one here, ACS, this is for security authentication, like for usernames and passwords. Where the ATM router or ATM switch, this would be stuff that's going on in the service provider network. So you'll see there's a lot of different types of devices that make up the network, but mainly from our point of view, we're just going to focus on the main four, which are the endpoints, the interconnections, so like the cabling between the devices, the routers, and the Ethernet switches.
Do you differentiate between fiber optic or copper interconnections?
You can. A lot of this really depends on your own type of naming convention. So if you were creating your own set of documentation, usually you would want to. Because let's say you're running Ethernet over a copper cable versus a fiber cable, there's going to be a difference in how those behave and how you would want to troubleshoot it. So a lot of times someone will use like a different color coding for the copper cables versus the fiber cables. So there's not really any hard and fast rules. It's just when you look at the diagram, can it make sense to you?